0.24 gram sample of a compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. So first thing we see, the mass of the compound is 0.24. So let's write this. Mass of compound equal to 0.24 gram. Then it contains 0.096 of boron. So mass of boron (0.096 gram). Now we have to calculate the percentage of boron. So when we calculate percentage composition of boron, it will be mass of boron over total mass, that is mass of compound, into 100. So mass of boron is 0.096, mass of compound is 0.24 into 100. So this will be now 0.096 over 0.24. In order to remove this decimal here on the top, what we do is, it is 96. There are three decimal places, so we multiply here by 1000. And in order to remove this decimal here, 24, we multiply by 100. And then this is the 100 from here. And when you cancel this out, you get the answer as 40%. So percentage of boron is 40%. Now when we want to calculate of oxygen, is the same way. Mass of compound is 0.24 gram, and now we need to know mass of oxygen. So mass of oxygen here is 0.144 gram. So the percentage of oxygen will be mass of oxygen over mass of oxygen over mass of compound into 100. So mass of oxygen is 0.144, of the compound, mass of compound is 0.24 into 100. Here again you remove the decimal, so it is 144. You will put here 1000 because there are three decimals, and for 0.24, 24, you will put 100 into 100. And when you calculate this, the answer comes 60%. So percentage of oxygen is 60%. When 3 grams of carbon are burnt with 8 grams of oxygen, 11 grams of carbon dioxide is formed. What mass of carbon dioxide will be formed when 3 grams of carbon is burnt with 50 grams of oxygen? Which law of chemical combination will govern your answer? Now the law that we use here is law of chemical combination of constant proportion. So in this law of constant proportion, they say in a chemical compound, the elements combined or are present in constant proportion by mass. And in this sum we have seen 3 grams of carbon combine with 8 grams of oxygen to give 11 grams of carbon dioxide. So 3 gram of carbon plus 8 gram of oxygen combined to give 11 gram of carbon dioxide. And in the next case, again we have 3 gram of carbon is now burnt with 50 gram of oxygen. But when we have 3 gram of carbon, it will act with 8 gram of oxygen. Although there are 50 gram present here, out of the 50 gram, it will act with only 8 gram. So 50 minus 8, 42 gram will be unreacted, because the amount of carbon you have taken is same. Here is 3 and here is 3. 3 always combines with 8. See, 3 will combine always with 8. So if you take extra, suppose you take 50, doesn't mean you will get more. It will combine with 8. So 42 grams will remain unreacted, and this will give you 11 gram of carbon dioxide. Carbon and oxygen are always in the ratio 3:8. So although there are 50 grams here, you put 50 grams, like in this case I've taken 50 grams, but out of the 50 grams only 8 will react with 3 grams of carbon. What are polyatomic ions? Give example. It is a group of atoms containing or possessing a charge. A group of atoms having a charge. Are called polyatomic ions. Examples: ammonia NH4 positive 1, nitrate NO3 minus 1. Write the chemical formula for magnesium chloride. So we have magnesium valency 2, chlorine valency 1, and then you crisscross it here. So you will now get magnesium Cl2, magnesium chloride. Now next we'll take up calcium oxide. Calcium valency 2, oxygen also valency 2. So if you crisscross it now, you'll get Ca2O2, but we take common out and we do CaO. So calcium oxide is CaO. Copper nitrate. So copper, copper's got 2 valencies, 1 and 2. They should mention it. However, we will take 2 here, and nitrate is NO3 valency minus 1. So you crisscross, you get copper 1, nitrate, you put a bracket because it's polyatomic 2. So this is copper nitrate. Next we get on to aluminium chloride. So aluminium Al plus 3, chlorine minus 1. So here we crisscross, so we have aluminium 1 Cl3. So this is aluminium chloride. Calcium carbonate. So calcium 2, carbonate is also 2. So we would have written crisscross. Here calcium will take 2, carbonate will take 2. So calcium 2, carbonate CO3, this is 2. So we take common out, so it is calcium carbonate, CaCO3. Give the names of the elements present in the following. First is quicklime. Quicklime is calcium oxide. It has calcium and oxygen. Then next we have hydrogen bromide. For hydrogen bromide, formula HBr, so is made up of an element of hydrogen and bromine. Then next we take baking powder. So baking powder formula NaHCO3, so that means made up of sodium, hydrogen, then carbon and oxygen. Next we take up potassium sulfate. So potassium sulfate K2SO4, and it is made up of potassium, then is sulfur, and oxygen. Calculate the molar mass of the following. So first we take up ethene. So ethene, it is C2H2. It's made up of 2 carbon plus 2 hydrogen, which is 2 carbon means 2 into 12, 2 hydrogen 2 into 1. You add them up and that will become 26 gram is the molar mass of ethene. Then the molar mass of sulfur. So sulfur is S8. So S8 means 8 atoms of sulfur. That is, sulfur is 32. So 8 into 32, which is 256 gram. Next is a phosphorus molecule. The phosphorus molecule is P4, which is made up of 4 phosphorus atoms. So 4, and the phosphorus is 31. Each one phosphorus is 31, so when you multiply you get 124 gram. Next is hydrochloric acid. Now hydrochloric acid is HCl, 1 hydrogen plus 1 chlorine. So 1 hydrogen is 1, chlorine is 35.5. So 1 plus 35.5, that is 36.5 gram. Next we get on to nitric acid. So nitric acid is HNO3. It is made up of 1 hydrogen, 1 nitrogen and 3 oxygen. So 1 hydrogen, 1 nitrogen we know is 14 and oxygen is 8. So 1 plus 14 plus 3 oxygen 8, oxygen 16. These will be given to you. So 14 plus 48, this works as 63 gram. All these values will be given to you, like carbon is 12, hydrogen is 1, sulfur 32, phosphorus 31, nitrogen 14, oxygen 16, chlorine 35.5. So these values will be given to you. All you need to substitute them. What is the mass of 1 mole of nitrogen atom? Nitrogen atom is just N. So here mass, given mass is what we need to calculate. Number of moles is equal to 1 mole, and molar mass, here we are dealing with just nitrogen atom, will be 14. Now the formula we are going to use here, since there is mass and number of moles, The formula we are going to use is number of moles equal to given mass over molar mass. If we put the value, number of moles is 1, they've given it's 1 mole. Given mass is x, we need to find. Molar mass we saw is 14. So 1 into 14 equal to x. So 14 equal to given mass. So this is the answer of A. Check and say mass of 1 mole of nitrogen is equal to 14 gram. Next, what is the mass of 4 moles of aluminium atom? Here I am calculating mass of 4 moles of aluminium atoms. Now remember, aluminium is 27, the atomic mass. So mass I need to find, that is my question. Number of moles is equal to 4, and molar mass, this is just aluminium, so molar mass is 27. Now since this involves mass and number of moles, is the first formula I've got to do. Number of moles equal to given mass over molar mass. Now number of moles is said is 4, so we put here 4. Given mass is x, we don't know. Molar mass is 27. They've given here molar mass 27, which is fixed for aluminium. So 4 into 27 equal to x. 108 gram equal to x. So mass of 4 moles of aluminium equal to 108 gram. Next, we have to find 10 moles of sodium sulfide, Na2SO3, 10 moles of sodium sulfide. So we are finding mass of 10 moles of sodium sulfide, SO3. So number of moles is 10. We have to find the mass. So given mass is a question mark, so we put x, and molar mass, we need to know the molar mass of sodium sulfide. Now to find molar mass of sodium sulfide is made up of 2 sodium, 1 sulfur plus 3 oxygen. 2 sodium, sodium is 23, sulfur, its fixed value is 32, oxygen is also fixed, and 1 oxygen is 16. So this is 46 plus 32 plus 48. So molar mass comes as 126 gram. Now we are going to use the formula first formula, number of moles equal to given mass over molar mass. Molar mass is m. So number of moles here is 10, given mass is x, molar mass here is 126. So 126 into 10 equal to x, given mass. So gram. So x equal to 1260 gram, which means now the answer 10 moles of sodium sulfide, the mass is 260 gram. Convert into mole. First 12 grams of oxygen gas. So given mass, (12 gram), Here we need to know number of moles. Number of moles is a question, so we take it as X. Molar mass of oxygen gas. Oxygen gas is O2. So this is O2, which is 2 oxygen. 2 oxygen means 2 into 16, that is 32. Now here we are going to use the first formula. Number of moles equal to given mass over molar mass. Now number of moles we don't know, that is our X, that is what we need to find. Given mass here is 12, molar mass is 32. This answer will be 0.375 mole. So for this we can write 12 gram of oxygen gas, O2 is oxygen gas, is 0.375 mole. Next we'll find how many moles in 20 gram of water. How many moles in 20 gram of water? So we have 20 grams. So given mass is 20 gram. Number of moles we need to find. See how many moles. So number of moles is our question, and molar mass. Molar mass of water, that is H2O. 2 hydrogen plus 1 oxygen. Hydrogen is 1, oxygen is 16. So 2 plus 16, 18 gram. We use the first formula. Number of moles equal to given mass over molar mass. So the given mass here is 20 grams of water, and the molar mass of water is 18. So when you divide, this is 1.11 mole. So 20 gram of water equals 1.11 mole. Next, convert into mole 22 gram of carbon dioxide. So how many moles in 22 gram of carbon dioxide? So we need to find number of moles is a question. 22 gram is given mass. Given mass 22 gram. Carbon dioxide. So molar mass of carbon dioxide. Carbon dioxide is made up of 1 carbon plus 2 oxygen. 1 carbon is 12, that is fixed. Oxygen is 16. So we have 12 plus 32, that is 44 gram. We use the first formula because here we have to know moles and given mass. Whenever there is given mass and moles, we use the first formula. Number of moles equal to given mass over molar mass. So number of moles, given mass is 22 over 44, that is 1 by 2 moles. So the answer is 22 gram of carbon dioxide equal to 1 by 2 mole. What is the mass of 0.2 mole of oxygen atom? This is just oxygen atom, so it is O. If it was given oxygen gas, it would have been O2, but this is not given to us. It was the oxygen atom. So number of mole 0.2. The mass we need to calculate, and here the molar mass of oxygen, important oxygen atom, this is very important, so it is just O, which is 16. The formula we use is the first formula, number of moles equal to given mass over molar mass. Now the number of moles is given as 0.2. The given mass we need to find out, and the molar mass is 16. So here this is 16. So we'll have 0.2 into 16 equal to given mass, that is 3.2 gram equal to given mass. So which means now 0.2 mole of oxygen atom equal to 3.2 gram. Next, what is the mass of 0.5 mole of water molecules? So mass of 0.5 mole of water molecules, H2O. So mass we need to find, number of moles equal to 0.5, and molar mass. Molar mass of H2O, which is made up of 2 hydrogen plus 1 oxygen. So 2 into 1 oxygen is 16. So 2 plus 16, which is 18. So molar mass is 18. Here again we use the first formula, number of moles equal to given mass over molar mass. Number of moles is 0.5. Given mass we don't know. Molar mass is 18. So 0.5 into 18 equal to given mass. So 0.5 into 18 is 9. So 9 gram equal to given mass, which means now the answer 0.5 mole of water equal to 9 gram. Calculate the number of molecules in S8 present in 16 gram of solid mass of solid sulfur. So mass of sulfur equal to here 16 gram. We have to find the number of molecules. Is a question. Now here moles is not mentioned at all. There is no mention of number of moles. It is not given nor it is asked. In this case we always use a third formula, and the third formula says given mass over molar mass equal to number of molecules over Avogadro's number. So let's put our values here. The given mass is 16. Now the molar mass we haven't calculated. Let us calculate the molar mass of sulfur. Molar mass of sulfur. Sulfur is S8. So it is 8 into sulfur, that is 8 into 32. And 8 into 32 will be 256 gram. So here I will put molar mass 256. Number of molecules we need to find. This is our question. Over Avogadro's number, that is 6.022 and 10 raised to 23. So here when we cancel, this will be, here 1s are, 16s are, so you'll do 1/16 equal to number of molecules over 6.022 10 raised to 23. So 6.022 10 raised to 23 over 16 equal to number of molecules. And here the answer, when you calculate this, will be 3.76 into 10 raised to 22 molecules. You can cancel 16 and 6 points, means you'll do 6.022 over 16. So to remove this decimal, you write 6022 over 16 into 1000 into 10 raised to 23. Then you cancel and you get your answer. So in 16 grams of sulfur, how many molecules are there? There are 3.76 10 raised to 22 molecules. Calculate the number of aluminum ions present in 0.051 gram of aluminum oxide. So mass of aluminum oxide, which is Al2O3, the mass they said is 0.051 gram. Here we have to know number of moles, number of molecules, not moles here, number of molecules of Al2O3. We need to find molar mass too. Molar mass of Al2O3, which is 2 aluminium plus 3 oxygen. Now aluminium has been given 27, 3 oxygen is 16, so that would work out to be 54 plus 48, and that is 102 gram of molar mass of aluminum oxide. So let's find out how many molecules of aluminum oxide are present. So we will use a third formula, given mass of aluminum oxide over molar mass of aluminum oxide equal to number of molecules of aluminum oxide over Avogadro's number. So let's put the values. The given mass is 0.051, molar mass 102, number of molecules we need to find. This is, remember, molecules of Al2O3. Avogadro's number 6.022 10 raised to 23. So let's find this, how many molecules are present of aluminum oxide. So we need to find X here. So we'll do 51 over 102. To remove the decimal, I multiply by 1000, and this is 6.022 10 raised to 23. This will cancel, ones are, twos are. So here I end up with 6.022 10 raised to 23. This is 2 into 1000 equal to X. So here again I can cancel, and this becomes now 3.011. So 3.011 10 raised to 23 minus 3 of this 10 raised to 1000 is minus 3, so it's X. So 3.011 into 10 raised to 20 is number of aluminum oxide molecules. So this is one part. There's another part of the sum. Now, one molecule of aluminum oxide contains 2 ions of aluminium. Why 2 ions? It is Al, this is Al2O3. So here there are 2 aluminium and 3 oxygen. So we have 2 aluminium, 1 molecule. How many molecules do we have here? We have 3.011 10 raised to 20 of aluminium oxide. How many ions will it have? It will have 2 into 3.011 10 raised to 20, which is 6.011 10 raised to 20 ions of aluminium. The question here is to find out how many ions of aluminium. So now I can write that we had 0.051 gram of aluminium oxide, and how many ions were present of that aluminium ions? In that they were present 6.011 10 raised to 20 ions. This part is a little extra because they asked for aluminium ions. If they asked just for aluminium oxide molecules, it would be here, but they asked for ions.